Given several random variables, we can consider the probability of an extreme value. If the maximum is m, then all must be less than or equal to m. If the minimum is m, then all must be greater than or equal to m. And if some are greater than some value a, then at least one is greater than a. And if some are less than a, then at least one is less than a. So, for example, let's suppose an insurance policy covers losses due to fire, theft, and pterodactyl attack. Seriously, that's all our special effects budget can get? If the losses are independently and exponentially distributed with means 5, 2, and 1 respectively, what is the probability that the maximum loss exceeds 3? So if the maximum loss exceeds 3, then at least one loss is greater than 3. But remember, consider the complement. This is complementary to all losses are less than or equal to 3. We'll use the cumulative distribution function. Since the losses due to fire are exponentially distributed with mean of 5, then the cumulative distribution function will be similarly for the losses due to theft and to pterodactyl attack. Since the losses are independent, the probability that all are less than 3 will be. So the probability that at least one loss exceeds 3 is the complement. Or we could take a different probability. Suppose bids for an item are uniformly distributed on 0.1 theta to 1.1 theta, where theta is the amount the seller paid for it. 4 bids are obtained. If L is the least and H is the greatest, find the probability that the least is less than theta, but the greatest is greater than theta. Since there are 4 bids and theta is our given value, note that if 0 bids are less than theta, the least value is not less than theta. And if all 4 bids are less than theta, the greatest is not greater. So exactly 1, 2, or 3 bids have to be less than theta. Since this is uniform probability distribution, the probability a bid is less than theta, well, that's actually 90% of our interval, so that's 0.9. And so the complementary probability is 0.1. And so we can use the binomial probability distribution to find the probability that 1 bid is less than theta, 2 bids are less than 3, or 3 bids are less than theta. And these will be and so we can add them together to find. And so the probability that 1, 2, or 3 bids are less than theta is 0.3438. And so that's the probability that the lowest and highest bids bracket the original purchase price.